Hello, students. So welcome to our lesson of today. Today, we are going to talk about proportions, and we are going to have two parts. And in this lesson, we are going to focus on part one. Let us do this discussion to discover what proportion is. Now, a bookshelf has a size as shown in the image below. Now, this is just the image, but the length and height that are written there, they are actual. You understand? When you measure it as a real bookshelf, you will see 80 centimeters as the length and 86 centimeters as the height. But since this is the image, the centimeters or the length and the height, they are not 80 and 86, okay? Because we cannot put 80 and 86 centimeters on a piece of paper, so we have got to reduce it. So this is just the image. Now, find the ratio of the length to the height of the shelf from the given information. Now, from this information that we are having, we are going to get the ratio of length to height as 80 to 86. 80 to 86. Now, that is the ratio that we have. Part two, find the ratio of the length of the height of the shelf by measuring from the image. Now, we are going to measure this image and see what is the length and height. Okay, please get your ruler and go ahead and measure the length and the height. And this image is on page 17 of your textbook. Okay. So when you measure accurately, you will see that the length is 4 centimeters and the height is 4.3 centimeters. Okay. Now, the ratio of the length to the height of this image will be 4 to 4.3. You see that? Now, are these two ratios equivalent? This ratio, 80 to 86, is it equivalent to 4 to 4.3? Let's discover if these two ratios are equivalent. Remember, we check if the ratios are equivalent using the cross multiplication method. Let us see the ratio 80 to 86. Let's write it as a fraction to be 80 out of 86. And the ratio 4 to 4.3, let's make it 4 out of 4.3. Now, when we do cross multiplication, we are going to have 80 times 4.3, 80 times 4.3. Now, you see that 80 times 4.3, we are going to get 344. Now, let us get 86 times 4. 86 times 4. 86 times 4, still we get 344. 44. Now, you see that these two parts, this one, 80 times 4.3, it gives us 344. Also, when we get 86 times 4, we get 344. What does this mean? It means that the ratio 80 to 86 is equal to the ratio 4 to 4.3. Now, I hope you understand that. So these two ratios are equivalent. Let's look at part 4 of our discussion. An equation showing the equivalence of two ratios is called proportion. Now you understand that if we have an equation like this one that shows that these two ratios are equal, it then means that this is what we call proportion. So it means that if we say that 80 to 86 is equivalent to 4 to 4.3, then this kind of equation, it is what we call proportion. I hope you understand that. Okay, if you see two or three ratios that are equivalent, it means that those ratios are proportional. It means that that kind of an equation, it is what we call proportion. And we are going to use this equation that we call proportion to find the missing parts of the two equivalent ratios. For example, if we say that, if we know that 80 to 86 is equal to, let's say, x to 4.3. So we can be able to use this equation to find the missing sign. I hope you get that. Now, for instance, we can say that we have got 80 out of 86 is equal to x out of 4.3. And now, when we use cross multiplication, we get 86x is equal to 80 times 4.3. And now we get x as 80 times 4.3 divided by 86. And this will give us 4. Now, you see that we can use proportion to find the part that is missing. Okay, let us get some examples. Part 1, if x to 4 is equal to 15 to 20, find the value of x. Okay. We know that x to 4 is equal to 15 to 20. Now, we can say that x out of 4 is equal to 15 out of 20. And then we go ahead and use cross multiplication so that we get 20 times x, that will be 20x. It is equal to 15 times 4. And x, it will be 15 times 4 divided by 20. And then x will be, let's check. If we divide 4 by 4, we get 1. 20 by 4, we get 5. And by 5, we get 1. 15 by 5, we get 3. So it means that x is equal to 3. I believe that you have understood that. Okay, let us get example number 2. Given that 4x to 9 is equal to 7 to 3, calculate the value of x. Okay, let's go ahead and get x. You see that this is an equation that is talking about proportion. Okay, so we get 4x out of 9. The ratio 4x to 9, we make it a fraction as 4x out of 9. It is equal to the ratio 7 to 3, which we will write as 7 out of 3. Now from there, we do cross multiplication. When we do cross multiplication, it means that we are going to have 4x times 3 is equal to 7 times 9. Now, 4x times 3, this will give us 12x. And this will be 7 times 9. Now, x will be 7 times 9 divided by 12. Okay. If we reduce 9 by 3, we will get 3, and 12 by 3, we get 4. So that we will remain with 7 times 3 out of 4. And so x will be 21 out of 4, which is the same as 5 and 1 out of 4. So it means that therefore x is the same as 5 and a quarter. So I think we have seen how proportion is important for us to know the missing part. Okay, let us talk about example number 3. A map has a scale of 1 to 300,000. If a road has a length of 3 centimeters on a map, calculate the actual distance. Now, I believe you understand what a map is. For instance, if we are going to talk about the map of Thailand, it is like a picture that shows how Thailand is, okay? It is showing all the parts of Thailand. But now, we make it as an image so that it fits on a paper. Now, you cannot get the whole of Thailand, you put it on a paper like, let's say A4 paper. It cannot happen because a paper is very small. So we use the scale to reduce the actual space, the actual distance, so that it can fit on any size of paper that you want. Now, that's why the scale is very, very, very important on a map. Every map must have a scale. Now, this scale tells us that when we have 1 centimeter on a map, it actually means that it is 300,000 centimeters, which is the actual distance. So when you see that, for instance, you have a distance of 1 centimeter on a map, it does not mean that the real distance of that place to another is 1 centimeter. But for this scale, it tells us that it will be 300,000 centimeters. So that is our scale. Now, on a map, the scale is 1 to 300,000. If a road has a length of 3 centimeters on a map, what will be the actual distance? When we have a length of 3 centimeters on a map, what will be the actual distance? This is the question that we need to answer. Now, normally, the distance is measured in kilometers. Okay? Because the distance is always long, so we cannot have the distance in centimeters. Centimeters is the smallest unit. Maybe you may have distance in meters if it is shorter, but when you are talking about long distance, you will be using kilometers. Now, let us change and we write our scale as, we have got the distance on the map, distance on the map. Let's show that we are doing the solution. So we have distance on the map. On the map, let me just write map. The distance on the map to the actual distance, the real distance. Now, we have 1, 2. Now, on the map, let's show this distance in centimeters. Let's show the distance on the map in centimeters, but the actual distance, let's make it in kilometers. And remember, we know that 100,000 centimeters, they make 1 kilometer. So if we have 300,000 centimeters, we will have 3 kilometers. Now, instead of writing 300,000, let's write 3. But this 3 is in kilometers. Okay. Now, this is the first ratio. Let's look for another ratio. On the map, we have 3 centimeters. The actual distance, it is what we are looking for. Okay. Now let's say that this actual distance, let's call it X. Now, these are 2 equivalent ratios. Now let's say 1 out of 3 is equal to 3 out of X. Now, let's do cross multiplication so that we have 1 times X is equal to 3 times 3, so that X is equal to 9. Okay, so it means that the actual distance, is 9 kilometers. So it means that when on the map we have 3 centimeters, it means that actually the actual distance is 9 kilometers. I hope you understand that. Okay. Now, if the distance between 2 stadiums is 7.5 kilometers, find the corresponding distance on the map. Okay. Remember, our scale is, the scale is on the map, we have 1 to 3. Okay. And this will be equaling to, if the distance between 2 stadiums, this is the distance, the actual distance is 7.5 kilometers. Now, this is the distance on the map we don't know, and the actual distance is 7.5. Now, we need to know the corresponding distance on the map. Okay? Now, let's say that this is, let's call it any unknown. Let's say that it is K. Now, let's write it as a fraction. We say 1 out of 3 is equal to k out of 7.5. Okay. Now, we get k times 3 to get 3k is equal to 1 times 7.5. And k is equal to 7.5 divided by 3. And k is the same as 2.5. Now, this answer is in centimeters, because remember, this is centimeter on a map. This is kilometer, the actual distance. This is centimeter on a map. This is kilometer, which is the actual distance. So we say that, therefore, the corresponding distance on the map is 2.5 centimeters. I hope you have understood that very well. Now you can see the importance of proportions, or the importance of equivalent ratios. Okay. Now, I would like you to do practice on page 15, 18, 22, and then you look at exercise 1B, you answer question number 1. So let's stop here for today, and we meet again later in another lesson. Goodbye.